2b, what we call example 2b. Now this is the example. So the previous one is theta A 0, theta B 0. Now we have theta A non-zero and relative n translation. So let's see what happened to this case. So let me go back to this particular things again. Okay. Now this is the second example, example 2b. So there is relative n translation, which is represented by delta over L, and also there is a n rotation. So the first thing that we do is looking at the n moment equations again. So we write down the moment n moment equations MAB, which is this. So now you notice that these terms appear now because theta A is non-zero together with this term because there is the relative n translation. The same thing for MBA. Same thing for MBA. So we have this, but now we have alpha F theta A appear now. Okay. And together with this term, which is due to relative n translations. So this is still the first step. After we identify here what is a non-zero and is there any relative n translation or not, then write down these two equations. So the next thing is we have two equations to write down now, two equilibrium equations. The first one is the same as in example 2a. You look at the whole members here and take moment at A here. And we take the moment equilibrium equation of moment at A. So this is what we get, P delta minus MBA equal to 0. So this is the first moment equilibrium equations. And the second one that we are going to look at is MAB, which is, this is a pin now. This is a pin now, meaning that we have another equations, equilibrium equations corresponding to pin, which is moment at pin location is 0. So MAB is 0. Okay. Of this member, NA is pin. That's why MAB is equal to 0. So we have two equations, equation 1 and equation 2. So the next thing is what we do is we again substitute MBA from here into these equations. Then we substitute MAB from here into these equations. Then we will get equation in terms of theta A and delta over L. Theta A and delta over L coming from this equation by substituting this and substituting this again. So finally, what we want to get is we get into two equations where it involves theta A and delta over L. So from that two equation, which is coming from here, we get into two equations that finally in the two equations, we see that theta A and delta over L is involved in that two set of equations. And that two set of equations can be finally represented in matrix form in this way. We write the two equations that we simplified from here, or in order to get two equations involving theta A and delta over L. And that two equations can be represented in matrix form in this way. And finally, in order to get non-trivial solutions, which is what is the value of KL in order that this is non-zero. So to get non-trivial solutions, so the determinant of this matrix here must be 0. Okay, so the determinant of a matrix, 2 by 2 matrix, this is a 2-row, 2-column matrix, so you should know how to get the determinant, which is this one multiplied with this minus this multiplied with that. So that will be the equation that we will obtain by applying these equations to get non-trivial solutions. So from there, again, we get a set of equations. We get one equations that we need to solve to get KL. Okay. Now, I would like you to, I would like you to go through this process to try to get to this equation. I will give you these, the content of these equations here, and you try to go through this process and to make sure that you are able to get to these equations, the content of this matrix here. So the content of this matrix is alpha n here, and here is negative alpha f, and here we have negative alpha n plus alpha f, and here is a bit more lengthy, so let me write in 2 rows. This is alpha n plus alpha f minus k l. So this is actually coming from these two sets of equations. We have to substitute what is MBA, MAB in terms of theta A and also delta over L. Then remember what we have gone through in the previous example. We want to factor out the EI over L. Then that is the first step. And then we want to also make the delta over L appear in these equations. So by doing that, finally, and you rewrite them in matrix form, this is what you are going to get. Okay. Then to find the determinant of this 2 row 2 column matrix will be this multiplied with this minus this. Okay. This one multiplied with this whole thing minus this multiplied with that, make them equal to 0. Okay. So this is a very lengthy equations involving alpha n and alpha f and also KL. So that is this equation that we need to solve to get KL. Okay. And to solve this, again, you can make use of this Excel spreadsheet. Assume a series of value of KL and then calculate alpha n and alpha f for different values of KL. Then substitute them into an equations which is equal to determinant, and then try to find the value of KL where it changes in the Excel calculations, the column, it changes from positive, negative, or negative to positive. Then you can identify where is the range in between what value and what value is the answer for KL. Okay. So that is the process of solving this example 2b. And this example, we happen to know that the effective length for this example is equal to 2L. So that means the P critical for this example is pi square EI over 2L squared. Okay. And the value of KL for this effective length and for this P critical actually should be pi over 2. Okay. So when you're using Excel, you should find the value, the answer for KL, which will make these determinant functions changes from positive to negative to identify where it is. It should show you this value here, where the KL, the actual value of KL, the solution for KL is actually equal to pi over 2. Okay. Or it is. So that is how we solve this example 2b, where you have non-zero n rotations theta a, and also you have possible n translations. So that will give us the solutions process for example of the structures of a problem where there is n translations. Okay, so when there is n translations, there is additional moment equilibrium equation that we need to consider. We need to consider this delta in the moment equilibrium equations. And from there, after that, we try to find the final solutions where we can use that. We can use that to look for non-trivial solutions, which is shown here. So to summarize again, so when we have the relative n translations, then first thing, of course, we still need to write down the n moments, which is from these two equations. Then after that, if there is n translations, then we need to form an equilibrium equation using the whole column, okay? Using the whole member or the column members here by taking moment at one end, and we form these equations. Then finally, we try to factor out the EI over L from these equations here first. And then after that, we try to make delta over L appear here by going through this process. And finally, we get to the equations where we can use the conditions to get non-trivial solutions to find the answer for KL here. And after that, when you get the KL, you can get the P critical. The same thing for this example where you have n rotation. So n rotation appear now in the n moment equations together with the relative n translations. Then here we have two equations now that we have to formulate. One for the whole column here, taking moment at one end, and we get this moment equilibrium equations. Consider the whole members. Next, we take the moment equilibrium equation at the joint here, where the theta A is non-zero here. So theta A is non-zero here. This is a pin condition. So we have a second equilibrium equation, which is MAB must be 0. So these two equations will be solved together to get two sets of equations involving theta A and delta over L. Then finally, in order to get equations where we can apply the conditions of non-trivial solutions, which is determinant of this must be 0, then we get an equations where we need to solve to determine KL. And after we get KL, then we can get P critical. And to solve for KL, the equations here are normally complicated, so we need a kind of trial and error method. Okay, so to try some values of KL and then determine where the KL, the value, approximate value of KL should be by determining where is the range between what value and what value. So that is the example on, that is the solution process using slope deflection equation method. Okay. Using slope deflection equation method. Now, together with the slope deflection equation method, applying to the solving of cases where there is no relative n translation, I have already gone through with you how to apply slope deflection equations to determine P critical. So now let me see if you have any questions.